All right. I don't know why this got to 100%, but it didn't say. But it did finish it. I don't know why it says it's not finished. Hmm. Let me just do something before so I don't lose that. Yeah, I don't know why that's doing that. All right. Let me try that. Um, oh, take 3. Come on. All right. Okay. So what are we going to do here? How are we going to get g of 2x?
You need to prove L'Hopital's rule first.
L'Hopital's rule. What is how do we know we're doing L'Hopital's rule?
Because the limit as x approaches -2 of g of 2x minus 4x equals 0.
How do you know that? How do you know that?
I did my work.
My question is, how do we do g of 2x? The limit of g of 2x as x approaches -2.
It's starting to happen.
What did you do to get the limit as x approaches -2 of g of 2x?
Find g of -4.
Well, okay. How do I find g of -4?
Plug it into that integral that they give you.
So, yeah. So g of 2x is the integral from 2 to 2x of f of t dt, right?
Yeah.
So the limit as x approaches -2 of g of 2x is the limit as x approaches -2. Well, no, it's equal to the integral from 2 to -4 of f of t dt. Okay? Everybody got that? Because 2x is approaching -4, so it's approaching the integral of 2 to -4. Okay? So now how do I get the integral from 2 to -4 of f of t dt?
It's the opposite of the integral from -4 to 2.
Okay, that's one way to think of it. And that's equal to?
10 minus 2, -8.
10 minus 2. You need to show the 10 minus 2. Okay? You need to show, well, I wrote the wrong thing there, but you need to show how you get those things. Like, you know, when we're doing integrals of like linear pieces and semicircles and stuff like that, I always show the work to get that area, right? So I'm
Yeah.
always showing how I get the ultimate integral. So you need to show your work that leads to that number.
It's -2 or -8. The answer is negative.
Oh, because it's, yeah. Sorry. Yeah. Okay. So that means that the limit as x approaches -2 of g of 2x minus 4x is equal to -8 minus 4 times -2, right? Which is 0. Okay. And then I got to find the limit as x approaches -2 of e to the x squared minus 4 plus x plus 1. And what does that equal to? That's the easy one.
1 plus -2 plus 1.
Thank you. So
L'Hopital's rule applies.
thank you. So that limit is equal to the limit as x approaches -2 of, I got to take the derivative of g of 2x.
2g prime of 2x.
Yeah, that ends up being a little more confusing than I want to do. I want to do it this way. So we wrote out g of 2x is equal to the integral from 2 to 2x of f of t dt, right? So I can differentiate that integral. So what is the derivative of the integral from 2 to 2x of f of t dt?
F of 2x. dx dt. Possibly.
Not dx dt. No, there's no dt in here. It would be something dx. The derivative of something with respect to x. David Senator, where on earth are you?
The derivative of 2x times the derivative of f of t.
No. Both of you got half of it right. Let's put them together.
Derivative of 2x and times the derivative of f of 2x.
No, we're not derivative. It's not the derivative of f.
F of 2x minus f of 2.
So it would be capital F of 2x minus capital F of 2, right? And we're back from the fundamental theorem thing, which you then differentiate. And the derivative of capital F is small f. That's how we developed it. So this would be capital F of t from 0 to g of x, right? So that's capital F of g of x minus capital F of a. But if I want to differentiate, figures, I don't leave myself enough room here. What's the derivative of capital F of g of capital F of g of x?
G prime of x.
Thank you. And what's the derivative of capital F of a? Capital F of a is a
Constant, so 0.
0, yeah. Capital F prime is small f, isn't it? So I don't take the derivative of that function. I just evaluate that function there, but then I have to multiply by the derivative of that, right? So it's what?
2f of 2x.
2f of 2x. Very good. Okay. So I get 2f of 2x minus 4 over 2x e to the x squared minus 4 plus 1, right? So what's happening to 2f of 2x as x goes to negative 2? Well, the argument is going to negative 4, isn't it? So what's happening to f as you're approaching negative 4?
It approaches 0.
It approaches 0. So that first term is approaching 0. So the numerator limit is
Negative 4.
negative 4. What's the denominator limit? Dave, are you unable to social distance? Is that why you have your face covered? What's the limit of the denominator? Negative 3 is correct. So 4/3 is the final limit. Okay. All right, part B. Find the absolute maximum of g on the interval -6 to Justify your answer. What do I have to do first?
Find the critical points.
Find the critical points. How do I find the critical points?
Find where f g prime equals 0.
Okay, so I got to find, yeah, so I got to find when G prime equals 0, yeah. So do I know anything about G prime?
It's equal to f of x.
That is true. That statement that I just wrote down there, if that does not appear in your answer, then you lose a whole bunch of points because you need to make that connection using the fundamental theorem that G prime of x is equal to f of x. Okay? If you just start going ahead and tell me x values that are 0 on the graph without connecting G prime to the graph, you don't get any credit for that. Okay? You have to tell me why you are looking at the graph of f in order to find that. So, when is f of x equal to 0?
-4, 0, and 2.
-4, 0, and 2. And then I got to look at the endpoints, right? -6 and 2. So this was brought up in the other class. When we first did this candidates test thing, remember I think I made you guys write that G is continuous on the closed interval. Therefore, I can use extreme value theorem or something like that. So, I mean, officially, you should make that connection. But I've graded a bunch of these over the years, and I've never seen that required on the exam. So you don't actually have to make that statement here. Okay? It's not wrong if you do, and as a matter of fact, it's really good if you do. But it's just not something that's going to be graded on the exam. And just to kind of put a bow on it, I would basically state that G is differentiable, therefore it is continuous on the interval -6 to 2, so I can use the extreme value theorem applies, right? Like that's what I would say there. But I've never seen them require it, so I wouldn't worry about that on this type of question. Can I exclude any of the x values? I mean, it's not horrendous doing this one if you don't exclude any, but are there any that I do not have to check?
-4 and 2, because that's where it goes from, not -4 and 2, 0, because it goes from, no, sorry. It is -4 and 2 because it goes from negative to positive. The graph goes from
Negative to positive. All right, so I agree with -4 because that's an interior critical point, right? So it's an interior critical point and it is a local min, so therefore it is not going to be a local max. I mean, an absolute max. 2 is, I agree that 2 is a local min on the graph of G, which still probably is not going to be able to be a local, an absolute maximum, but because it's an endpoint, you need to check it. Okay? That's just how you play the game on the candidates test. You always check the endpoints. Plus, I mean, checking 2 here is nothing, right? It's the integral from 2 to 2. So it's not really that bad to check. So we can exclude x equals 4 if you want. I'm sorry, x equals -4, because at x equals -4, g has a local min. Okay? So that leaves me with checking g of -6, g of 0, and g of 2. So g of 2 is easy, integral from 2 to 2. That's 0. G of 0 is the integral from 2 to 0 of f of t. And that is equal to what? From 2 to 0.
It would be the opposite of the -2, so it would be +2.
Yeah. So it's +2. You can either make it the negative of the integral from 0 to 2, so that would be -2. Or you can just say, oh, I'm going left, right? And if I'm going left, then I have negative function values and negative deltas. Those are positive values, aren't they? So I've got a positive value integral, so it's +2. You can flip those so that they go from right to left if you want, but you don't have to if you're adept at using them in the other order. And then I go from 2 to -6. And in this case, because it's a little complicated, maybe you do want to do the opposite from -6 to 2, right? So that's negative, and you got to tell me what you're adding up here. So what do I write in the parentheses there?
-2 plus 10 plus -5.
Yep. So that's -3, right? So we get, so the question asked us, find the absolute minimum of G. Okay, so that's a value, right? More than likely, if this was on the exam, it would say, find the absolute minimum value of G. But, the way you can answer this so that you definitely are answering the question is G of X has an absolute max of 2 on the interval -6 to 2. It occurs at x equals 0. That's the safe way to answer the question, because now you've definitely answered it whichever way it's asking it, right? If it's asking you what x value the max is occurring at, you've answered that. If it asks you for the value, you've answered that, and you've explicitly stated each of those, okay? Giving a point 0, 2 is not a way to answer this question, because we don't know if you know which coordinate is the maximum value. Okay? All right, C. Evaluate the interval from -3 to 1 of x f prime of 2x dx. What do we do? Colin, what'd you do?
Sorry, I couldn't find a mic. Let me get my work up. Stupid thing. Integral. Oh, I did a U sub, it looks like. Can't be right. No, I did a by parts.
Okay, so what do you have as U?
U is x and dv is f prime and 2x dx. And du is dx and v is f of 2x over 2. So it's x time. The
Okay, so
integral
hold on.
from,
Let me just make sure everybody's good with this, right? So if we anti-differentiate f prime, right? The antiderivative f prime of 2x dx is a u sub, isn't it? Right? So u is 2x, du is 2 dx.
you forgot the x in the integral.
No. I'm doing dv,
Oh, okay.
right? So I'm taking the antiderivative of this. So I just want to make sure everybody knows why it's over 2. Okay? Because it's a u sub. So if I introduce the 2 inside, and we did this the other day, I can introduce a 1/2 out front, so I just neutralize that, and I'm really only multiplying by 1. Okay? So inside here, I have f prime of u du. And the antiderivative of f prime of u is
F of u.
f of u. So it's f of u times 1/2. Yeah, to you too. So it's f of u times 1/2, right? Okay, so that's where that comes from. Okay, so now I use the parts formula. U times v. Now, remember that this is a definite integral, so this needs to be evaluated from -3 to 1, doesn't it? So I'm just going to let that, I'm just going to do that later, but you have to do that evaluation. And then I get the integral from -3 to 1 of v times du. So 1/2 f of 2x dx. Okay? So now I got to think about this integral here. The integral from -3 to 1 of 1/2 of f of 2x. So, So I guess, so the first thing is, I'm going to pull that 1/2 out front. Well, I'm looking at the graph of f of x, aren't I? I'm not looking at the graph of f of 2x. It's a totally different graph. Okay? Now, let's think about this. So if I had 2f of x, that's a vertical stretch of the graph of f, isn't it? That takes f and stretches it vertically by a factor of 2, if it's 2f of x. If I have f of 2x, that is horizontally stretching this graph in some way. Okay? So I don't even know what the graph of f of 2x looks like, and I definitely don't know what the antiderivative of f of 2x is. So my best bet is to make the integrand look like f of x so I can then use the graph I have, isn't it? So here's how you do that. U sub. So if I do a U sub on this, u is still 2x, du is still 2dx. But unlike this up here, I'm actually going to switch to u. So I get 1/2 integral. So if x is -3, what's u?
-6.
-6. And if x is 1, what's u?
2.
2. So my new endpoints are -6 to 2, which makes me happy because I don't think I like endpoints from -3 to 1, do you? That's a little problematic on the graph that we're looking at, isn't it? To find that integral. -6 to 2, however, looks like we might be able to do something with that. F of u, and then dx is du divided by 2. So if I pull the constants all out, I get 1/4 integral from -6 to 2 of f of u du. Well, there's my f of x graph, isn't it? Because it doesn't matter what letter's in there. That's the graph that we're looking at, isn't it? So I get 1/4 times the integral from -6 to 2 of f of u. The integral from -6 to 2 is -5 plus 10 minus 2. So I get 3/4. Now, you might be thinking, oh my God, that's really hard. That's ridiculously hard. Well, it's a little challenging. I will give you that. But it's also something you can definitely expect on this year's exam. I'm not saying it's absolutely going to show up. I have no idea. But it certainly meets the criteria of how these exam questions are going to be written. The graphical stem and the abstractness of just calling something f neutralizes the calculator, right? And using u sub in this way also neutralizes the calculator and any outside things like Wolfram Alpha or something like that that might be able to do some problems if you gave it the equation for f, right? But there's no way for those things to do anything with the problem when it's written this way. So, I mean, I would expect something like this could appear on the exam. Okay, so now we can do our value. So we got to plug in 1 here. So it's 1 times f of 2 over 2 minus -3 times f of -6 over 2 minus 3/4, the number we got over here, right? Now, I can't leave the answer like this. I have to pull the numbers off the graph for f of 2 and f of -6. F of 2 is what?
Zero.
0. F of 6 is? I'm sorry, f of -6 is?
-5.
-5. And there is your answer. I got -33/4 when I did that, when I simplified that. But I would advise you not to simplify something like that. Okay? All right, part D. You good on the end of that, Colin? Just doing the evaluation here. Okay. Part D. The region R is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Write but do not evaluate an integral expression that gives the volume of the solid. So here's an example of why I advise you to read the entire question, okay? If you take up all 15 minutes doing parts A, B, and C and don't get to part D, then that's like a crime, isn't it? Because those of you who did part D, you know that it's really not very hard at all, okay? So you really need to make sure you read the entire question so that you know what you can do. You'll also know what parts are linked, right? Now, in the modern type of free response questions, there are fewer links between parts, meaning that there are several entry into the question. You can enter in part A, you could enter in part D if you wanted, right? So, you know, if you see something that you want to answer right away, do it. All right? And get to the other parts when you get to them. But by reading the whole question, you number one know, oh, geez, I know how to do part D. I'm going to do that right now. And the other thing is you know which parts are linked. And when you read the whole question, then you will even subconsciously your mind will be working on how to do that problem even if you didn't think of it consciously when you read the problem. Okay? So if you read all the way part E and then go back and start at part A, your mind has already seen part E, and so it will definitely be thinking about how to get to part E, and maybe by the time you get to part E, it'll be, if you may not have understood it immediately, you'll have an idea when you get back there. Okay? But remember that multiple entry point thing. You don't have to start with part A. Okay? Now, part B might rely on part A, so you might not be able to start with part B. But we could start in this question. I think you could start with any of the parts. I think they're all. I don't think any of them are linked together. Am I right on that? Obviously, part A is a L'Hopital's rule. You don't need anything for that. Part B, no, you can start with part B. You can start with part C. You can start with part D, and you can start with part E. So in this particular case, there were 5 entry points into this question. Okay. All right. So here we have a cross-section perpendicular to the x-axis, squares, right, but do not evaluate an integral expression. So we have squares, right? So, whoops. So popping up out of the board are squares. So what's the width of that slice?
dx.
Dx. What is the side of the square?
F of x.
F of x. What's the volume of the slice?
F of x squared. Dx.
Dx. F of x squared times dx. And so to get the volume of the solid, I simply integrate the volume of the slice over the interval. So integral from where to where?
2 to 5.
Of the volume of the slice. That is the answer to part D. That is all it is asking you to do, okay? There will not be any evaluating. Certainly it wouldn't ask you to evaluate that integral. You can't, because you can't get the antiderivative of that, okay? And we don't know what the graph of f of x squared looks like. So therefore we can't do anything with that either. So that's it. That would be worth 2 points. N points and integrand would be the 2 points that you'd have there, more than likely. This, by the way, part C would probably be worth 4 points, is my guess. I would grade it on 4 points. 1 for identifying the parts. Second for writing this line right here using integration by parts. The third point would be evaluating that integral, and the fourth point would be the answer. So that's how I would grade this. Okay? All right, let's get to part E. Part E. We get to party. Colin, what the heck? You're not jumping on that? All right. So for x greater than or equal to 5, the function f is not explicitly given, but f prime of x is equal to -4 times 1/2 to the x minus 5th power. If a sub n is equal to f prime of n, find the sum as n goes from 5 to infinity of a sub n, or show that the series diverges. So we're going to rewrite the summation, subbing in a sub n. So a sub n is f prime of n. So that just means I plug in n for x here, right? So I get -4 times 1/2 to the n minus 5. Okay, now, what should we do first that I've advised you to do when you are given a summation of an expression?
Nth term test.
No.
Don't you always check nth term test first?
Well, we're not. No. This, you want to get an idea of what this is, right? So what should you do first?
Write out the first few terms.
Write out the first few terms, yeah. That's what you want to do first. Then you can set a game plan for whether it converges or diverges, right? So if n equals 5, what's my exponent?
0.
0. So that's 1/2 to 0, which is 1. So it's -4 times 1, -4. Come on, go away. When n equals 6, the exponent is 1. -4 times 1/2 is -2. When n equals 7, the exponent is 2. Negative 4 times 1/4. Well, minus 1. Next term times a half. Okay, so
1/4.
now we have a sense of what it is, right? What have we got here? What kind of a
An
series have
approach-
we got? Huh?
P series?
Nope.
Is it biometric?
Is it what?
Geometric series?
Geometric. Did you say biometric?
I might have. I'm not sure.
Yes, it is geometric with what? What do we want to know about a geometric series?
R equals 1/2.
R equals 1/2. We want to know the common ratio, don't we? Since R is equal to 1/2, does that tell you whether we have a convergent or divergent geometric series?
Yes,
Because
R is less than the absolute value of 1. Or the absolute value, yeah, something like that.
so if it converges, then we can find the sum. And the sum is a fraction. What's in the numerator of the fraction?
A.
Which is what? Stands for what?
I'm not sure, to be completely honest.
Well, I mean, yeah, okay, you know the formula, but you got to know what the heck it means. So you can put a number in there.
First term.
First term. I don't remember it as A over 1 minus R. I remember it as first term over 1 minus the common ratio. First term over 1 minus the common ratio. -8. So a common mistake here would be to answer -2. You have -4 divided by a half. So a common mistake is to make that -2, not -8, right? Now, hopefully you could look at that and say, geez, that doesn't make any sense. Now, in fact, you should stop right here, shouldn't you? So you don't make that mistake. Okay? But if you did write -2, you should be able to look at this sum and realize -2 doesn't make any sense at all, does it? And if you start at -4, then you're going, which way is right for you? This way for you guys? -4, then you're going to the left as you're adding, aren't you? -4, -6, -7, -7.5, right? You're not even going towards -2 when you're doing the partial sums here, are you? Okay? So hopefully that would help you down the road. Okay, so the plan. I'm going to put together that assignment with those 4 questions, which I said, as I said, are really 2 stems with a whole bunch of parts. It looks like 4 questions, and there is a little bit of overlap. Like I think at least a couple of the questions in each part with the same stem are the same. So you don't have to answer it twice, obviously, if it's the same exact question. It's going to cover most of the BC only unit 10 topics, chapter 10, okay, that are actually being tested. So those are the ones I definitely want to go over. I still haven't seen anything that credibly does anything with the ratio test as a part. I'm still on the lookout for that, and I'll try to do that in class on Friday. But any ratio test that you're asked to do would only be a ratio of numbers. I mean, a ratio test on a series of numbers, not on a Taylor series, because Taylor series are not being tested. Okay. So I'm going to be on the lookout for that kind of question. I want you guys to have these done by class on Friday. Post your answers as a regular homework assignment. Okay. And this is, yes, it's in addition to the other homework assignment. And as I said, if there are any questions you have, I will be available. You just need to send me an email, and we can hop on Zoom and get it taken care of. If you do send me an email, make sure you are looking at your email so that you can see my response. I should respond pretty quickly as long as I'm not in the middle of something. Okay. And then we can get any answers done. We'll make it a reasonable time. I'll be available up till 10 o'clock. All right. I mean, I do sleep, so some of you may not, but I do. All right. So that's where we're at. We're hopefully well on our way of being well prepared for Tuesday. Make sure if you have not tried your setup in the demo that you get that done as well, so that you know you can accomplish the submission of your thing in the 5 minutes. Make sure you're using at least 3 pieces of paper to do it, so that you're taking 3 pictures just to add a little bit of time in there. Okay. And I think that's it, unless anybody has any questions. Everybody good? Okay, so I'll see you Friday morning at, geez, could Senator get out of here any faster? I didn't even say it was over yet. So I'll see you Friday morning at 8:30. What's the chances he shows up?
Bye-bye.
All right. See you Friday.